I'm Bruce Segee. I'm the Henry R. and Grace V. Butler Professor of Electrical and Computer Engineering here at the University of Maine. And this is a video about a project course, ECE 498, that happened in the spring semester of 2011.
I'm Craig Verrill. I'm a student at the University of Maine. I helped work on the keyboard and USB functions.
I'm Tim Brim, and I also helped work on the keyboard USB functions.
I'm Forrest Flagg. I worked on the AV conversions.
I'm Jason Monk, and I worked on managing everything, so I played a little hand in everything.
My name is Andy Sheaf. I'm working towards continuing education credit for my professional engineering license, and I worked on the USB code.
My name is Tyler Lean. I worked on the PCB design and the schematic for this project.
So the motivation for this project is we wanted something that would be widely used even by people who aren't technically savvy. We wanted to have a device that plugs into a USB port but doesn't require any special software or any special hardware, any special operating system. The form factor that we decided on was a keyboard. That is, when it plugs in, the user's computer is convinced that the user has just plugged in a USB keyboard that is supported by Windows, Linux, Mac OS X, and any other operating system that you'd care to come up with. The data gathering then becomes essentially a series of keystrokes. You plug this thing in when you have a spreadsheet, for example, or a text document open. It types in the data, and then when you unplug it, you're able to process the data.
So this is the device here, and here's a quarter for scale. On the device, we have an integrated USB port where it can plug right into the computer. We have the AVR microcontroller, a programming header, and the temperature sensor.
Okay, so I want to give a quick demo of the device in operation. This is the board right here. I've set up at a computer. I've launched a Google spreadsheet, which is an online spreadsheet. Just clicked into column A1. What I'm going to do is I'm going to plug this in. I'm going to immediately start getting keystrokes from it. It's going to send samples every 2 seconds. I've got a hot butane soldering iron in my hand. I'm going to heat the temperature sensor up to about 100 degrees or so, and then watch it cool down and plot the results. In it goes. Hot exhaust port. $107, $114. That's probably good. Hand this off camera to somebody who knows how to handle hot objects. And the temperatures stopped going up and started going down. Okay, and that's probably done what it's going to do. So it's cooled down more or less to room temperature. I'm going to remove it so that it stops sending me data. And then in the spreadsheet, what we've got, get rid of that, get rid of that, get rid of that, get rid of that. All right. Gives actual voltage reading, gives the temperature in degrees C, gives temperature in degrees F. What I'm going to do is I'm going to get just the numeric portion of the degrees Fahrenheit equal SPLIT, using the split function. I'm going to split cell C2 on the capital F, and then when I fill this down, about like that, it will give me the numeric values. I'll put a nice heading at the top, select the column, insert chart, And taking all the default values, I will click OK. This is me heating it up. And this is the heat actually percolating through the case into the sensor. And this is the sensor cooling off in a nice exponential decay back down toward room temperature.
So advanced features on the premium UMeter models include a rechargeable battery, which will recharge every time you plug it into your USB port, and flash memory. These two things will enable the user to capture sensor data values remotely without needing to be plugged into the computer.
We've also included functionality for up to 3 additional sensors for a total of 4, as well as RS-232 to USB conversion to allow the user to connect more advanced sensors such as GPS or accelerometers.